Hello my dear students, welcome to Eshwari channel. This is your Eshwari ma'am. Students, in this video we are going to learn about Bohr's atomic model. So this is from the chapter atomic structure. So students, you know that in an atom, this is the nucleus and this is the orbit, and here you have electrons revolving like this. So in an atom, nucleus will be in the center and electron starts revolving around the nucleus. So Rutherford said that in his model, electrons move around the nucleus in the circular orbit. Okay, so but one disadvantage of this model, one disadvantage of Rutherford's atomic model is, if the charged particle is accelerated, it should lose energy. So here electron is a charged particle, so it should lose energy. As it loses energy, it comes closer to the nucleus. It gets attracted towards the nucleus and finally it will fall into the nucleus and no more an atom can exist. But this doesn't happen in nature. So this is one of the disadvantage of Rutherford's model of atom. So this was clarified in Bohr's atomic model. So in Bohr's atomic model, what Bohr said is, this is the nucleus of an atom and electron will be revolving around the nucleus in a fixed orbit. So as long as the electron is present in the fixed orbit, it neither loses energy nor gains energy. So such orbit, we call it as stationary orbit. So this orbit is called as stationary orbit. So as long as electron is moving in the stationary orbit, it will not lose energy or it will not gain energy. So that is the first point given by Bohr's atomic model. That is, electrons revolve around the nucleus in a fixed orbit. Called as stationary orbits. So this is what said by Bohr. So second, what he said is, so here let us take one more orbital here, second orbital. This is the second orbit. So now electron is present in the first orbit. Here first orbit and this is second orbit. So electron is present in the first orbit. So when electron jumps from first orbit to the second orbit here, what happens is, it gains energy only then it can jump from first orbit to second orbit. That is, energy should be supplied here. So in the form of photon. So when energy is given to the electron, it absorbs energy and jumps to higher energy level. So here what happens is, electrons absorb energy and jumps to higher orbit. Orbit or energy level is one and the same. Orbit or energy level. So here this can be calculated as delta E is equal to E2 minus E1. So the difference in energy will give you how much of energy is being absorbed by the electron. So now if the electron is present in the higher orbit, so if the electron is present here, what happens is that electron loses energy. So it will give away the energy and jumps to the lower energy level. So it gives away energy. So electron from higher energy level loses energy and jumps into the lower orbit. So you can write here, electrons emit energy and jump to lower orbit. So here delta E can be calculated as delta E is equal to E1 minus E2. So the difference in energy is how much of the energy is being given away by the electron. So this is the second point which is said by the Bohr's atomic model. Angular momentum of the electron is integral multiple of nh by 2 pi. So what is angular momentum? So you know that this is the nucleus and electron is revolving around the nucleus in the circular orbit. So if an object is moving around the nucleus in the circular path, we can calculate its angular momentum by the formula mvr. R is the radius from the nucleus to the electron. This distance is the radius. So mvr is angular momentum. So angular momentum you can substitute here mvr. mvr is equal to nh by 2 pi, where n value can be 1, 2, 3, 4 and so on. So it is an integral multiple. You cannot take 1.5 h by 2 pi. So here n cannot be decimal 1.5 or 2.5 h by 2 pi. So it should be always integral multiple 1, 2, 3, 4. So now if you are getting the doubt like how we got h by 2 pi. So h by 2 pi is given by Bohr. After doing certain experiments, he found this relation. So he could not explain why exactly he has taken h by 2 pi. Okay, this is one of the disadvantage of Bohr's model. By various experiments, he could relate this equation, but he couldn't explain why exactly he has taken this relation as h by 2 pi. So now angular momentum can be calculated using this formula, that is mvr is equal to nh by 2 pi, where m is mass of the electron, v is velocity of the electron, r is the radius and h is the integral multiple, n is the integral multiple and h is called as Planck's constant. So fourth point is, students see here, this is the nucleus of the atom and electron is revolving around the nucleus. So here electron experiences two types of forces. What is that? So one is called as the outward force, which is called as centrifugal force. Centrifugal force. And one is the inward force, which is known as electrostatic force of attraction. Electrostatic force. So electrostatic force of attraction will be pulling the electron towards the nucleus and centrifugal force will be pulling the electron outward. So here we can give the equation for centrifugal force as F1. F1 is the centrifugal force, is equal to mv square by r. And let us take electrostatic force of attraction, which is given by F2 is equal to K Q1 Q2 divided by r square. So this is centrifugal force. Centrifugal force, and this is electrostatic force. Electrostatic force. So now here F2 is equal to K. What is Q1? Q1 is charge on the atom. So here the charge on the atom is nothing but Z. Z is atomic number and the total charges present in the atom. So in place of Q1 we can write ZE, and Q2 is charge of the electron. This is charge of electron. So charge of electron we can take it as E divided by r square. So this is equal to K ZE square. E into E square divided by r square. So electrostatic force is equal to K ZE square by r square. So now F1 should be equal to F2, isn't it? So if F1 is equal to F2, only then electron will be present in that orbit. Suppose if you think that centrifugal force is more, then what will happen? Electron will be thrown away from the atom. Suppose if electrostatic force is more than the centrifugal force, then electron will be pulled into the nucleus. So if it want to stay in this orbit, then both the forces should be equal. That is, centrifugal force must be equal to electrostatic force of attraction. That is, F1 should be equal to F2. So now let us substitute for F1. mv square divided by r is equal to F2 is kZe square divided by r square. So now here r and r we can cancel. So here we will be getting v square is equal to m, you shift to the other side, you will be getting kZe square divided by m into r. So this is what we will get. Velocity square is equal to. So now what Bohr has said is angular momentum. Angular momentum is mvr. mvr is equal to nh by 2 pi. So this is what we wrote in the third point, isn't it? What Bohr said is angular momentum is equal to nh by 2 pi. So now let us square this on both the sides. So square on both sides. What you will get is m square v square r square is equal to n square h square by 2 square is 4 pi square. So now in place of v square, let us substitute this value. That is m square kZe square by m into r square is equal to n square h square divided by 4 pi square. So now you can cancel r and r, 1 m and m you can cancel. So finally you will be getting here r is equal to, r you keep here, remaining terms you shift to the other side. So n square h square divided by 4 pi square m k ZE square. So this is what you will get. So now what is n here? N is number of orbits, and what is h? H is called as Planck's constant and its value is 6.6 into 10 to the power of minus 34 joule second, and then pi is constant, you know, 3.14, and then m is mass of electron, which is 9.1 into 10 to the power of minus 31 kg, and then E is charge of the electron, 1.602 into 10 to the power of minus 19 coulomb. And what is Z? Z is the atomic number. So Z is the atomic number. So now if you substitute all these values, you will be getting R is equal to 0.529 into 529 n square divided by Z angstrom. So using this you can find out the radius, 0.529 n square divided by Z. So here R is directly proportional to n square, that is number of orbits, and R is inversely proportional to atomic number of the atom. So using this relation we can calculate the radius. So now let us take one small numerical and find out the radius. And one more thing is, students, this relation we can use only for hydrogen and hydrogen type of atoms, that is having only one electron. Like hydrogen you can use for calculating in hydrogen, and then helium He plus, then lithium Li2 plus, then beryllium Be3 plus. Only for the system having only one electron we can use this formulas. So now let us calculate for one numerical how to find out the value of R. The question is, calculate radius of second orbit of Be3 plus. So Be is beryllium. Okay, for Be3 plus atom. So this is applicable for calculating the system containing only one electron. So here they have asked for second orbit. So N will be equal to 2 and Z is the atomic number. So for Be atomic number is 4. So write the formula R is equal to 0.529 N square by Z angstrom. So this is the formula, substitute in this. 0.529 N square is 2 square divided by Z is 4 angstrom. So 2 2s are 4. 4 and 4 will get cancelled. So you will be getting R is equal to 0.529 angstrom. So this is how you calculate the radius. So I hope the concept is clear to you. I'll meet you in the next video.